And we are live. So I'll show this quickly here. So basically, this is the Finland Azure user group tips and tricks session. We have these roughly bi-weekly. We have a couple more coming this week or this year still. And as most of you probably know, Finland Azure user group is the largest Azure user group in Finland. And we have roughly 1.7K members right now. And this year we have been focusing on the virtual events. So last week we had a live panel with some MVPs and RDs. And this is kind of a shorter session where we go through a specific technical aspect that somebody has learned recently. And if you want to see these recordings later on, feel free to check out our YouTube and Meetup pages, which you can like this. And I will let Glenn take over now, so feel free to continue. And I'll stop share.
I'm going to share my screen right now. Just let me see if I can make sure that, no, this shouldn't be shared. Sorry for the hiccup. I'm sharing my other screen. This should be fine. This should be way much better. So I just noticed in the introduction of Pasi that this should be around 30 minutes. I was planning to go a bit longer, but what I will do is I will cut straight down to the most important parts and make sure that we end up around the half hour or the 35 minutes. So thanks everyone for attending. My name is Glenn. I'm one of the founding fathers of Azure Belgium. I'm an Azure MVP and I've been involved in quite some IoT and cloud projects in Belgium. So the last couple of years I've been focusing around everything regarding IoT. So if you have questions afterwards, drop me a line on Twitter. And the demo I will be presenting today is available fully on my GitHub page. So take a look at those pages if you want. So quick note about Azure. I guess most of you already know that Azure is focusing on everything platform as a service. We have been doing that since 2011, and we now have offices both in Helsinki, Finland, and in Ghent since the beginning of this year. And we also have quite some cool logos from Microsoft. And I should really update this one as we are now a 7-time gold partner. But as said, let's quickly start our talks about IoT. And just as a recap, IoT is all about things, getting those things connected and creating some insights on top of those things. So when you start an IoT project, one of the biggest decision is that you need to make the decision if you go full platform as a service or take the more software as a service approach. Azure has a wide range of offerings around that, but be aware that the biggest advantage when going full platform as a service also comes with the biggest challenge, the fact that you're in full control of everything. So let's quickly go over the Microsoft portfolio. As already mentioned, there's a couple of software as a service offerings. IoT Central is there. you could see IoT Central as, with all respect, the Office 365 for IoT, if I can say that. It's gets you started quickly, allows you to hook up devices really quick, create some nice dashboarding, and that with minimum effort. And then there's the IoT services, all the different platform as a services in Azure, where you can create your own IoT platform that you need. Some core components there: IoT Hub, time series insights, and the new digital twins. And then, of course, there has been a big focus on everything Edge. IoT Edge is there. Think about all the Azure services that have been moving to the Edge and are available as Edge modules. So that's a quite big support that is available over there. And then more on the device side, there's Azure Sphere, the whole Windows IoT operating system, and the IoT Edge devices. So what we've seen over the years that IoT has been there. Usually IoT projects were all about getting your assets connected. So the typical story of your things, connecting those things and creating some insights and actions upon that. But what we're seeing is that customers and people that are using IoT solutions, they want to take that a level further, and they want to build their IoT solution around a physical model or a physical environment. And then slowly starting to emerge in having those connected environments where you build solutions that provide a more natural approach to IoT solutions. So it's all about virtually representing the physical world with digital twins, digital environments. So, and that immediately takes us to the new Azure Digital Twin service. And the Azure Digital Twin service created to leverage or to help you to build those next generation IoT solutions. So it is there to help you to model your environment, keep those models up to date with live streaming data or from IoT systems or from business systems, and allows you to output all the data that you have to time series insights, to storage, or to an analytics program or service. So the Azure Digital Twin service that is available right now is, if I'm not mistaken, still in preview. I think at Build or Ignite, it was at Ignite, it was announced that it would be G8 somewhere in November. So we're if I'm looking at the date, we're still November. So I'm expecting that to go GA soon-ish. But as already said, it's actually the second version of this preview. And the difference between the first version and the second version is that that the modeling is now based more on open standards. It is using the modeling language that is also available from IoT Plug and Play, and so on. It is based, it allows you to have a more flexible topology definition. It allows you to input external compute, while it used to have only JavaScript support, and so on and so on. So let's first of all talk about the open modeling language, which basically forms the core of your digital twin. So you can create custom domain models using the digital twin definition language. The digital twin definition language is completely aligned with IoT Plug and Play and with the time series insights data model. It is based on JSON LD, excuse me, JSON LD, and therefore it is following that standard. You can describe your digital twins via a couple of areas. First of all, there's the properties. A property is a data field on your digital twin and represents, how do I say it? Represents a certain state of your twin. Important to mention is that these properties are stored on the twin itself and therefore have some storage in the background. Then there's telemetry. Telemetry, as you say it is measurements from events, IoT sensors or data that are flowing through your digital twins. So telemetry is not stored on the twin itself. Well, it's not stored forever on the twin. You can see it as a sort of streaming set of data. Think event hubs where the data on your hub is valid for a couple of days. It is the same approach. The telemetry is not forever stored on your digital twin, but it's flowing through your twin as a streaming approach. And then there's the components. You can see that as a bit of the interface. Imagine that you're digitally building a cell phone. You can then, for example, create a camera component and then use that camera component to identify the front and the back cam of your cell phone. And then maybe the most important part of your digital twin is the relationship. And the relationship allows you to define how digital twins interact with each other. So what is the relationship of your twin with something else? During my demo, you will see that I've modeled out my house. So you will see that my house has a relationship with a couple of floors. My floors will have relationships with rooms, and you can really map those relationships out and create a graph of those relationships. So those different models and those twins together, they form a semantic relationship to connect your twin in the graph. Let me just maybe quickly jump to Visual Studio to show you how this modeling is done. So if we take a look, let me just close things down. So I hope this is visible. If not, drop me a line on the chat if it's not readable enough. So as you can see, this is a model that I'm defining as a digital twin model describing my house. So what you see here is just a JSON document that describes my digital twin. First of all, you have to give it an ID. And that ID is built up by using the DTMI prefix, and then you can give it a domain name, model identifier, and a version. So basically, you are building up that ID to identify the model that you're using. Type is interface. That is just a fixed value that you have to use as digital twin. Then a display name. I think that speaks for itself. Context, again, here that's just a value that That is a fixed value when you're working with digital twins. So again, the digital twin API and service is interpreting this context and making sure that this context is there. And then all remaining interface data is put here in the contents area. And this is really where you start defining your properties, your relationships, your telemetry, and so on. So as part of the demo, what I did is I gave my house two properties, one a construction year and another property called owner. And then maybe the important thing here is I've added another content of the type relationship. I gave that a name, and that relationship has a certain target. So in this case, I'm targeting the DTMI demo floor 1 ID. And if you would look at the floor I defined, you see here that I have another model defining my floors. So you can see here that my house is linked with the relationship with the target floor. And here again, we have the same principle. We give it an ID, some fixed values, and then inside the contents, there is the most important thing you need to identify. My floor doesn't have much properties, or doesn't have any relation, or doesn't have any measurements or telemetry. I just define my floor model as having relationship rooms. So again, same story. We're targeting the ID of the room here. And you can see here again the same build-up, the ID that we're targeting, and the most important, the contents here. So I have a property temperature and a property humidity. You're probably wondering, hey Glenn, those will probably be measurements. So why aren't you putting them as telemetry? So what I'm doing in this demo is I have, you see here, I have in my room a relationship to sensors. So I'm having the sensors here, and you can see here that I have the telemetry of temperature and humidity defined on the sensor, and another property firmware version, but that's not important. So what I will do in the demo is my temperature and humidity will flow through the system and update this digital twin with the data that is flowing through the system. Because I also want to have, because I want to have a more higher level view on the temperature and humidity, what I will do is with exporting the data, with using events, I will come back to that later. With using events, I will update further details of my twins based on the data that is streaming through the system. Therefore, I want to have my humidity and temperature also on my room as a property, so I can store those on the twin. But I will definitely come back to that later on how that is done. So once you have these models defined, what you can do is, first of all, maybe I should have mentioned that up front. So if you would go to Azure provision, I think I should zoom a bit more on this. If you go to Azure and you provision an Azure Digital Twins, what you get is a service. And that service is, with all respect, just a set of APIs allowing you to create those digital twins. So to make it more simple, there is a Digital Twin Explorer solution allowing you to visualize the digital twin environment that is here Unfortunately, this is not baked into the product yet, but I can imagine that that will come rather sooner than late. So as I mentioned, there is an open source project available allowing you to explore the digital twin. So what I did after creating these models, I've uploaded these JSON files to the digital twin service, making them available inside the digital twin itself. So if we would have a look, this is pretty bizarre. You see here that I have the house interface, the room interface, the thermostat, the floor, and so on. And if we even want, we could look at the model information. This takes some while. You could see here that this model is available inside the digital twin environment. And once you have modeled out those things, you've uploaded the models to your digital twins, you can start creating those digital twins and leveraging the live execution environment. So let me jump back to the slides. So we've created our model. We've uploaded our model to the digital twins through the API. I will show you the code in a couple of minutes, and then basically the whole story starts. What you do is you start leveraging the live execution environment. Basically, you start leveraging the runtime of digital twins. So once you have those models, you can start creating twin instances based on the models. So for example, what I will do in the demo is I will create a digital twin of my house based on the model. I will create 3 floors based on the floor model. I will create a couple of rooms based on the room model, and so on. As already said, the visualization is currently only possible via the Digital Twin Explorer. That is not baked in the system yet. Yeah, that's not baked in the system yet. Yeah, sorry about that. That is not baked in the system yet. So if you want to feed data towards the digital twin, you can input data via IoT Hub or any other data sources. Most of them by leveraging the API of the digital twin service. I will show you how that works, and that will probably raise some questions with everyone. What you can do is then hook up external systems by using eventing and data processing and so on. And the execution environment also comes with a query API, allowing you to live query the data available on the digital twin environment. Basically, the Azure Digital Twin Explorer is using that query API underneath to visualize that data for you. So next to that, you can offload the data to further storage or further analytics. You can route that through Event Hub, Event Grid, and Service Bus. And basically, this opens up a couple of additional scenarios for you. You can store that data in a data lake. You can connect to Logic Apps if you would like to do that, or you can connect to time series insights and have that historical series of data. Before we jump in the demo, I just want to explain what we will do, or how the demo looks like. Sorry. So first of all, you see here we have created our models in JSON. and we've uploaded them or made them available in Azure Digital Twins. What we will do before we start feeding the data with, before we start feeding the digital twin with data, we will interact with the digital twin and create our twins, create the relationships between them, and create that visualization. So once you have that digital twin set up, you can start feeding that twin with data. In our case, I have created some simulated devices. I have hooked them up with IoT Hub. And because the way digital twins currently is set up, you need to feed data towards digital twins through an API or by using the SDK. So therefore, to ingest data from IoT Hub to digital twins, you need an intermediate step with Azure Functions, but I will get to that later. Currently, there's no possibility to have that direct endpoint from IoT Hub to digital twins. So once we have that data flowing through our digital twins, we can, for example, hook up an external service. In our case, I've hooked up Time Series Insights to show you the graphical history of the device data. So let's jump. What I will do is I will jump to the code. So let me close this, and the code should be here. So so important here is I'm using the SDK available, so the digitaltwins.core, and that is using the APIs underneath. So how do you start creating twins, or how do you interact with the APIs of digital twins? So first of all, what you need to do is you need to create a dictionary that contains your model that you want to use. In our case, remember, this is our model ID, and the kind digital twin, again, a fixed value that you need to use. That metadata will then go into a twin data. Again, that has a dictionary. So you put that metadata in there, and you provide the additional properties that you have defined on your model. Remember, our house looked like this. So we have owner, construction year, and you see that these things are coming back on the twin. What you then do is you just call the method create digital twin async. You give that twin a certain ID. In our case, we just gave it an ID house, and we pass in the twin data. And basically, this is how you create your set of digital twins. So if we would look here for the floors, it's a bit simpler. We have some metadata. We're using the floor model, again, digital twin kind. If you remember well, we did not have any properties or additional values on our model for the floors. So we just can pass the metadata as the twin data and call the create digital twin async. So here in this set of code, what we're doing is we're calling the create digital twin async 3 times to create 3 digital twins, but with separate IDs. So we have 3 twins based on the same model, but each of them having a separate ID. so they will be handled as separate instances. Again, for the rooms, the same. For the sensors, the same. And then the interesting part starts. So here we've created the sensors as digital twins. So, and then it's all about starting to map out those relationships, as I mentioned. Again, here a bit of the same approach. You need a dictionary to basically define how your relationship looks like. You need to first of all specify the target ID. So in our case, the target ID is floor 1. Remember, we created a digital twin with ID floor 1, and that will come back here in. That will come back here in our target ID. Then you need to give the relationship name. The relationship name, if you remember well, our house had a relationship with relationship name floors, and that is coming back here. So that's the metadata you're passing, and then you can call the create relationship async. And if you look at that, you're saying, okay, I want to create a relationship on my digital twin with ID house. Please give that relationship this ID or this name, and please use this metadata to create the relationship. And basically, this is again how you build up those relationships. You see here that I'm creating relationships between my different floors. Here I'm creating mapping my kitchen to my first floor. I'm mapping my living room to my first floor, and so on and so on. Here is an example on how I am mapping my bedroom 1 to my thermostat 002, and basically this is how you create those things. And if you do that, you will see that the digital twin the digital twins instances will be created, and you will see the relationships between them. So if we would go back to my digital twin explorer, I'm just going to run the query here to see that is nothing there. So currently my digital twin is only having the models available. But if I would run that piece of code we just created, let's see what happens. So what I can do here is I will call the setup digital twin. So if all goes well, this should start creating those twins. So here it asks me to log in because this is linked with Azure Active Directory. So as you can see, he's starting to create the twins. Relationships has been created, and so on. So I saw a little error on top of that. So let me just quickly take a peek on what that is. Okay, this is just about I'm probably trying to re-upload the models again. I'm getting a 409 conflict because the models already existing. But next to that, you see that all the twins have been created. You see house twin, floor twins, different rooms, thermostats, and all those relationships have been created. So if we now go to the Digital Twin Explorer, hit Run Query, if all goes well, you should see that he's starting to create that interface. So what we did is from the models, by using the SDK, we've created these all these circles. Yes, we call that a circle. All these circles are digital twins, and they are linked with each other with a certain relationship. As you can see here now, there is some initial data available, but our sensors are just empty for now. So that brings us to the next step. Yeah, you can call them nodes. That makes sense. So now we are entering the next step. We have our model, we have our digital twin with the relationships. We want to start updating this this environment, this live execution environment, with telemetry, with live data, and so on. And this is where IoT Hub comes into play. So what I will do is I have here a device simulator. That is, I will already fire that up because to have some data to show at the end of the demo. So what this will do is this will just at regular intervals just sending some temperature and humidity to IoT Hub. Yeah, it's just your average device simulator for IoT Hub. So if we look at IoT Hub, let's take a peek at that one. We have, so let me just show you what has been created. So I've created a couple of devices here, just to have them as a separate device ID. And now, as I mentioned during the demo explanation, currently there's no way to directly hook up IoT data to digital twins, unfortunately. You have to use functions, and then functions on its own will use the SDK again to update the twin data. So, and a good way to hook up together IoT Hub with functions is to use Event Grid. So what we're using here is an event subscription. So basically, every time a device telemetry arrives on IoT Hub, an event will be thrown on the event grid and will be filtered out by the Azure Functions endpoint. So we have a function listening on the event grid of IoT Hub, picking up all the device telemetry messages that are being processed by IoT Hub. So, and if we would take a quick peek at how that function is written down, it's, as you can see here, this is written listening on IoT Hub, and it's just processing or taking out all the data from the event grid message, and then it's using, in our case, what it will do, it will update the twin property. It will update the twin property that is used for that device. You see here the device ID that comes from the IoT Hub device is the same as the digital twin ID here. So this is just for the demo to make it more easy. So as you can see here, it will update the twin property by calling the API underneath and calling the update digital twin async. If all goes well, we should, if we would click through these things, you can see here that these values are now being updated on the digital twin itself. I will zoom a bit as that this will make it more easy. So this is now the data coming from the sensors, and we see that our digital twin is being updated as we speak. You will, let me just click through them, that you actually see that, those data are refreshing. So what we have now, we have our devices. Our devices are sending data to IoT Hub, and we are updating our digital twin with the data coming from the devices. The next step is how are we able to update external systems? As I mentioned, we want to hook up, in our case, we want to hook up time series insights to have that graphical, that time series data of things. But imagine you can also offload the data to storage or to integrate your digital twin with some business processes. If we take a look on how that is done, again, then we would go to our digital twin environment. And if you're familiar with IoT, this will, if you're familiar with IoT Hub, this will look very familiar. You can define a set of endpoints, and an endpoint is nothing more, nothing less than a certain endpoint type. You can give it a name and give it a, provide your connection string over here. So currently there's only Event Grid, Event Hub, and Service Bus being supported. In our case, let's not save that. I've created an event, Event Grid, and an Event Hub endpoint. Once you have set those endpoints up, you can use those in the event routes. Again, very simple. In our case, what we want to do is we've set up a route that has in endpoint our Event Hub, and we filter on the Microsoft Digital Twins.twin.update. So every time a twin gets updated, this event will trigger, and it will put an event on the Event Hub. So remember, data is flowing through the system. Every time a new value or a new telemetry value is put on the twin, it will trigger an update because there's a new value over there. So this is being triggered, and then of course then it's all about demoing the next step. So we have our data on the Event Hub here, and then we just have time series insights connected to that environment. So let's take a look at time series insights to see if that data that we're processing is flowing through the system. So let me zoom a bit. So here you already see here those different sensors. So let me just add temperature for 1 to 3. This will look a bit weird because I've tested this setup this morning. So let's zoom here the last 18 minutes to see what is happening on the data. So you can see here that data is flowing in time series insights. I'm not going in details in time series insight because I guess I'm already a bit over those 30 minutes, but thanks everyone for staying along. So this data is flowing through time series insight, and this is just a way to demonstrate that that you can export the data of your digital twin to an external service. I see that there's a question from Paco. So yes, you're seeing that correctly, that this sensor is connected to both of my rooms. I just use this as an example to show you that these relationships don't have to be one-on-one, that there's multiple possibilities of creating a graph. So those relationships don't have to match one-on-one. You can have a twin that has multiple relationships and so on. I just, as a matter of example, I try to map that out. So this was a very quick walkthrough on what the capabilities were of Azure Digital Twins. Some important conclusions or takeaways that you need to take into account. The most important thing is that it's an event-driven approach. You can see that due to the fact that IoT Hub is not directly linked, you need to set up routes and endpoints to route the digital twin events to somewhere else. It has a full platform as a service approach, and you're controlling it by using the REST API underneath or the SDK. So it's all about talking with the SDK and talking with the API to set those things up. And the most important thing is that it's completely built around the ability to model your environment and to, with a very hard focus on the event-driven approach. With that said, I think I've ran 10 to 15 minutes over. Excuse me for that. If you have questions, just drop them in the chat. If you don't have time, just drop me a line on Twitter or find me somewhere online, or find me through Posse, and I will be happy to help you out with the things. Happy that the time was just a suggestion, so I'm off the hook with that.
Yeah. All right, but if there are no questions, I'll end the recording here, and you can find this in the YouTube channel afterwards. Thank you, Glenn.
Thank you everyone for attending, and hope to see you soon.